Welcome back to another video. If you are familiar with neural networks, you must have surely come across the term activation functions. Activation functions help define the output for a given set of inputs by deciding whether to activate or deactivate the neurons to get the desired output. In this video, we will be discussing the different activation functions used in neural networks. Before moving forward, I would highly appreciate if you could take a moment to hit the like button and smash that subscribe button and turn on bell notifications so that you don't miss any updates. Stay tuned. Let us look at the different activation functions one by one. Binary step function. The binary step function is a threshold-based activation function, which means that the neurons are activated above a certain threshold. If the value is below a certain threshold, the neurons are deactivated. We can represent it mathematically as follows. The binary step function is used when we want to create a binary classifier. This is also one of the limitations of binary step function, as it cannot be used when there are multiple classes in the target variable. Linear activation function. The linear activation function is a straight line activation function in which the activation function is directly proportional to the weighted sum of inputs. Linear activation function can be mathematically represented as follows. An advantage of linear activation function over the binary step function is that it allows for multiple outputs when compared to two outputs in a binary step function. A drawback of linear activation function is that changes made in backpropagation will be a constant, which is not good for learning. Another drawback of linear activation function is that the last layer will always be a function of the first layer, limiting the neural network's ability to deal with complex problems. As a result, a neural network with a linear activation function simply becomes a linear regression model. Sigmoid activation function. The sigmoid activation function is one of the most widely used activation functions. It uses a probabilistic approach for decision making, and the output ranges between 0 to 1. The sigmoid function can be mathematically represented as follows. A drawback of the sigmoid activation function is that the gradient value diminishes as it is backpropagated through the network. As a result, by the time it reaches layers close to the input, it may not have much effect. This problem is referred to as vanishing gradient. A small gradient value means that the weights and bias of the initial values will not be updated effectively, and as a result, lead to an overall inaccuracy of the whole network. Tanh activation function. The tanh, or the hyperbolic tangent activation function, is an activation function that is very similar to the sigmoid function. The only difference is that the tanh function is symmetric around the origin, and the output will be in the range of -1 to 1. Tanh functions can be mathematically represented as follows. However, similar to sigmoid function, the tanh function also comes with vanishing gradient problem. Relu activation function. A rectified linear unit, or relu, is one of the most widely used nonlinear activation functions. The output for the positive inputs can range from 0 to infinity, but when the input values are below 0, the function outputs 0, which hinders backpropagation. This problem of relu activation function is referred to as dying relu problem. The dying relu problem can be overcome by using a leaky relu function. Relu function is far more computationally efficient than sigmoid or tanh function, as all the values on the negative axis will have the value of 0, making the network run faster. Leaky relu. Leaky relu is an improved version of relu activation function that helps to solve the problem of dying relu. Leaky relu achieves this by defining all the negative values of x as an extremely small linear component of x. By making this small modification, the left side of the graph becomes a non-zero value. Softmax activation function. The softmax function, or the soft argmax function, is an activation function that is used for multi-class classification. The softmax activation function can be mathematically represented as follows. The softmax function is used mainly in the output layer for neural networks that need to classify the inputs into multiple categories. Now that we have discussed the different types of activation functions, the next question comes: which activation function to use? Since selecting an activation function is critical when building and training a neural network, experimenting with different activation functions will allow you to select the best activation function and achieve better result. However, here are some points to consider. The softmax function is used mainly in the output layer. The sigmoid function works well for classification problems. For deep learning models, it would be advisable to experiment with relu as they are computationally efficient. Leaky relu can be used to solve the issue of vanishing gradient. Leaky relu function is also preferred when there are dead neurons in the network. That brings us to the end of this video. Hope you got an idea about the different activation functions used in neural networks. Don't forget to leave a like and hit the subscribe button as it encourages me to make more videos. Thank you for watching and see you in the next video.